Hi everyone, this is Sir Leimar C. Arsena and you can call me Teacher Lay for short. So we're now in the week 8 of our first quarter and our topic is solutions of systems of linear equation into variables. So we're done discussing how to solve linear equations into variables, getting its solutions, and this time we're talking about systems. Okay, systems means um, it is composed of two or more linear equations. Right. So to solve this, we have three different ways. What are those? We can solve systems of linear equation into variables by graphing. That's the first. Second, through substitution. And lastly, by elimination. Okay, we will discuss one by one. Before that, let us recall a bit. Okay, let's recall a solution. What is a solution? It is an ordered pair in the form of x, y, enclosed in parentheses that satisfy the given linear equation into variables. So ordered pair is also called coordinates. Okay? Also, x alone is called abscissa, the set of all x. Okay? Abscissa, and then we have x coordinate. Y is called ordinate or y coordinate. Now, since the graph is a line, we all know that, so all the points within the line are said to be the solution of the equation. So we have our goal, which is to get the solution of the system. What ordered pair or pairs will satisfy the system? Okay? So let's move on. System of linear equations contains two or more equations, okay? However, in a system of equations, we're looking for a unique ordered pair that will satisfy both equations. I said that a while ago. That ordered pair is the coordinates of the point of intersection of the two lines. So we are looking for the point of intersection. If there is no point of intersection, no solution. If there is point of intersection, there is solution. Okay? Looking at these three graphs, the first graph shows an intersecting lines, right? Showing intersecting lines, therefore, there is point of intersection. And that point of intersection is called to be the solution. Okay? Very good. Next, for the second graph, it shows that there is no point of intersection, so therefore, there is no solution at all. Okay? And for the third one, we have the coinciding lines. So therefore, all the lines within these lines are solutions. There are many infinite solutions if you have this kind of graph. Okay? And let's recall also, what do you call the system if we have intersecting lines as our graph? We call it consistent independent. There is one solution. Parallel, inconsistent, since there is no solution. And coinciding, we call it consistent dependent. Okay, so there are infinitely many solutions. Now let's start with the first way of solving systems of linear equation into variables, that is by graphing. So you can check your SLM or self-learning modules in mathematics on page 34. You can see this. By graphing illustrative example, graph the equations in the coordinate plane. That is the first thing to do. We're going to graph the equations in coordinate plane. Now, for us to graph it, recall how we're going to graph an equation, okay, in a xy plane. So given this negative 2x plus y equals 2 and negative x plus y equals negative 1, you recall how to rewrite a given standard form of equation into a slope-intercept form. And as you can see in your graph, or in this graph, from negative 2x plus y equals 2, it became y is equal to 2x plus 2. Meaning, it is now in the slope-intercept form wherein we can get the y-intercept, which is 2. And then the slope is positive 2. So here it is. You see, you look at the arrow. Y-intercept, positive 2, and then slope is positive 2. Rise over run, 2 over 1. So 1, 2, pataas, and then 1 going to the right. So that will be the graph. And the other line or equation is y is equal to x minus 1. This time, the the y-intercept is negative 1 and the slope is positive 1. 1 and then 1. So we have this. As we extend the line, we will see there is a point of intersection. Therefore, the solution is negative 3, negative 4. The coordinates of the point. Okay, meaning when you substitute negative 3 and negative 4 to x and y in each of the equation, it will satisfy both of the equations. Okay? That is how we're going to solve for system of linear equations in two variables by graphing. So let's do it by my own example. Now, solving systems of linear equations by graphing, given the system x minus y is equal to 3, 2x plus y is equal to 0. Now, first things first is rewrite the given equation into slope-intercept form. Okay, as we rewrite it, this will be the new form. Y is equal to x minus 3 and y is equal to negative 2x. Okay, is it clear? I think no need for me to rediscuss how to rewrite linear standard form into slope-intercept form. Now, after this, what are we going to do is to graph. Yan. You make the Cartesian plane, of course. You put the x and y axis and then graph. Okay? This first line is the graph of the first equation, which is y is equal to negative 3, y is equal to x minus 3. Negative 3 is the y-intercept. Look at here. Ayan. So we have that negative 3 and the slope is positive 1. Rise over run, 1 unit upward, 1 unit to the right. So we have this line as the graph. Next, for the second one, the y-intercept is 0. So here, 0 at the origin. And then, slope is negative 2. Slope is negative 2, 1, 2. Okay? Going downward. Since it is negative, then positive 1 to the right. 1 unit to the right. So, the graph will be this. As you can see, there is point of intersection. They intersect, right? So, the point of intersection with the coordinates 1 and negative 2 is the solution to the system. Okay, meaning 1 and negative 2 will satisfy the given. Let's check, of course. Okay, for the checking part, the first equation x minus y is equal to 3. Let's check if 1 and negative 2 is correct. So we have 1 minus, substitute values, then negative 2 is equal to 3. And it is correct. 3 is equal to 3. It satisfies the system. Another one, the second equation, the same. It satisfies the equation. So therefore, the solution is 1 and negative 2. Okay, so we're able to solve the system by graphing. Okay? But sometimes through graphing, let's say, hindi nyo talaga sumakto at an exact point that will give us integer coordinates, it's okay. Okay? So, ang graph will be effective only if exactly integers ang coordinates ng point of intersection. Okay? Let's move on. Another example. X is equal to y plus 2 and x is equal to y minus 3. Again, rewrite it into slope-intercept form. Okay, that's the slope-intercept form. Then graph. X minus 2. We have negative 2 here. And then 1 as a slope. Okay, so this one. Let's check. Okay. And then, second equation. That's the graph of the second equation. Next, what will be the solution? Sir, there is no point of intersection, so there is no solution. Very good. There is no solution to this system of linear equation in two variables. Okay, you may just write no solution. Okay, let's move to the second way of solving. Now, solutions of systems of linear equation in two variables by substitution. Let's do this. Again, in your SLM, page 34, by substitution. Solving systems of linear equations by substitution with 5 steps. Step 1, solve for one variable in one of the equation. Step 2, substitute the resulting expression into the other equation. Step 3, solve the equation to get the value of the variable. Step 4, substitute the value to any of the original equation to solve. Then step 5, write the values from step 3 and 4 as an ordered pair x and y and check. Okay? Let's have my own example. Given the system, again, the same system with what that we use in graphing. Let's check if we will come up with the same solution. Siyempre, dapat, right? So we have y is equal to x minus 3. That is the first step. Solve for one variable. Okay? So we solve the first equation, y is equal to x minus 3. So meaning the value of y in terms of x is x minus 3. Next, step 2, substitute the value. Let's substitute. We will replace y by its value, which is x minus 3. It will become 2x plus x minus 3 equals 0. Then simplify. So 2x plus x minus 3 is equal to 3x. Then 3x minus 3, we want to eliminate negative 3. So we add the additive inverse, which is positive 3, to both sides of the equation. So 3x minus 3 plus 3 is equal to 0 plus 3. We have 3x equals 3. We call that addition property of equality, okay? The use of additive inverse. Then, divide both sides by positive 3, we'll get x is equal to 1. Now, in this one, we use the first equation, right? What if we use the second equation? It is your choice, class. It is not required to use both. You just choose one. So, I'll just show you if we use the second equation. If we use the second equation, the value of y is equal to negative 2x. And we're going to substitute that to the first equation. Let's substitute the value of y, which is negative 2x. It will give us x minus negative 2x equals 3. And then, it will give us x plus 2x equals 3. Also, 3x is equal to 3. Divide both sides by 3 again. And the answer is x is equal to 1. The same. So, you can choose between the two which equation you're going to use as the for the step 1. Okay? Next, after getting the value of x of one variable, we're going to substitute it to any of the original equation. Let's say the first equation, x minus y equals 3, and the value of x is equal to 1, substitute. So therefore, we have 1 minus y equals 3, then addition property of equality, it will give us negative y equals 2. And then multiplying both sides by negative 1, so the y will be positive, y is equal to negative 2. And then what if we substitute the value of x in the second equation, it will give us the same, y is equal to negative 2. So, by this, we can say that our solution is 1 and negative 2. If you want to check, you may check it, okay? But again, we just proved that the answer in graphing is the same with this answer. So it is correct. We already checked that, right? Okay, very, very, very easy. Okay, let's move now with the third way, which is solving it by or through elimination method. Okay, by elimination, again, in your LM, solving steps, we have 4 steps. Step 1, write the system so that the like terms are aligned. Take note, we need to make alignment with the like terms. See to it that the variable to be eliminated have the same numerical coefficient, otherwise, multiply both. Okay, we will do that. If we have the same and the not the same numerical coefficients, okay? Then, second, eliminate one of the variables and solve for the other variable by addition or subtraction, okay? You should know when to use addition or subtraction operation, okay? Step 3, substitute the value solved to any of the original. Step 4, write the results in steps 2 and 3 as an ordered pair, x, y, and check. Let's do this. The same. Okay, we have the same given from graphing and substitution. So we can really check, okay, which one is the easiest, easier, and then the hardest. So it's up to us, no? It depends on our preference to know which is the easiest way for us. But then, if you use the tree, you can solve it. So you can use any. Okay, with this, what we're going to do first again is to write the system into alignment. Align. X minus y equals 3 with the like term. So, katapat ni x si x. Y, tapat niya si y. Constant, katapat niya si constant. Okay? Then, let's think of the way we can eliminate one of the variables. Can we eliminate x and 2x by just simply adding or subtracting them? No. How about negative y and positive y? Yes, right? Since y has negative 1 as numerical coefficient and y has positive 1 as numerical coefficient, they have this numerical coefficient the same, which is 1. So we just need to choose whether we're going to add or subtract. So how are we going to eliminate negative y and positive y? Are we going to add or subtract? Very good. We're going to add. So let's add the two equations. X plus 2x will give us 3x. Negative y plus y is 0. No need to write. So by that, we eliminated the variable y, right? Then 3 plus 0 is 3. We have 3x is equal to 3. That is how we eliminate, class. Then, solving for x, we have x is equal to 1 still. Okay? Next, x minus y is equal to 3. Then, substitute the value of x, which is 1. We'll get y is equal to negative 2. Is it easy for the elimination method? Yes. So we get x is equal to 1 and y is equal to negative 2. The other one, if we use the other one to solve for y, you'll get the same. So the solution is 1 and negative 2. So it is easy. Okay? How about this given? What if we have here 3x plus 2y equals 12, 12, then 2x plus 3y equals 13. As you can see, there is no same numerical coefficient. 3x, then 2x, they're not the same. 2x and 3y, they're not the same. How are we going to eliminate? So it is said in our step, we need to multiply both. Okay, so we need to think of multiplier that will give us the same numerical coefficient. Let's say we want to eliminate y. We need to make it the same coefficient. So 2y will be multiplied by 3, so it will become 6y. And then 3y will be multiplied by 2, so it will become 6y. That's our goal. So multiply the first equation by 3, then multiply the second equation by 2. And what are we going to get? So 3 times 3x is 9x, 3 times 2y is 6y, and 12 times 3 is 36. Second equation, 2 times 2x is 4x, 2 times 3y is 6y, and 2 times 13 is 26. Now, we have now common or same numerical coefficient, which is 6 for the y variable. How are we going to eliminate 6y? Are we going to add or subtract? Positive 6y, positive 6y? Yes, we're going to subtract. So 6y minus 6y is 0. So that's it. Let us subtract the two equations. So 9x minus 4x is 5x. 6y minus 6y is 0. Then 36 minus 26 is 10. Okay, let's continue. So solving for x, it will give us 2. Okay? Now, let us get the value of y by substituting x to any of the two given equation. So let's say the first equation. We have 3 times the value of x, which is 2, plus 2y equals 12. Then simplify, 6 plus 2y is equals 12. Then addition property of equality, 12 minus 6. We have 2y equals 6, therefore y is equal to 3. So our solution is 2 and positive 3. Let us check. So if we substitute x and y, 2 and 3 to x and y, we'll get 12 is equal to 12, which is, therefore, we can conclude that um, the ordered pair 2 and 3 satisfies both of the equation. Look, okay. Therefore, the solution is 2 and 3. That is how elimination is used in solving systems of linear equations. So, it's up to you to assess or to evaluate which one is easiest or easier for you to use. Okay? So, that's all. We have the graphing, we have the substitution and elimination method in solving systems of linear equations. Goodbye and thank you.